All right, you guys, I'm going to briefly go through and work out each problem on our Unit 1 review. Feel free to rewind, fast forward, speed it up, whatever you need to do to help you out. I'm not going to really go over these first three. I mean, I will briefly, but number one is just asking vocabulary, right? What is the difference between an exact answer and an approximate answer? So I've given some examples of that, right? Exact just means it's finite. Finite means it ends, right? Anything that's not an infinite decimal, that goes on forever. Or if it is an infinite decimal, then it's written as an improper fraction. For example, 1/3 would be an exact answer, but 0.3 repeating or 0.3 just rounding it off would not. So exact just means you can write it as a fraction or it's a finite decimal. Approximate means it's some sort of infinite decimal that you have rounded, like to the nearest tenths or hundreds or whatnot. Again, in this class, we never ever round unless a problem specifically asks us to do so, okay? And then the next question is asking about the difference between monomials, binomials, and trinomials. So these are all names we give to polynomials. Remember, a polynomial is just a fancy word for expression. That means many terms. And then a monomial just means it's one term, binomial 2, and trinomial 3. And then I've just given some brief examples off to the right there. On number 3, the difference between an equation and an expression. So you definitely need to know this, right? An expression is when you have no equal sign and it's just a collection of terms. And all you're allowed to do is simplify an expression. Simplify means to get rid of parentheses and combine like terms, right? That's what it means to simplify. An equation says two expressions are equal to each other, which means it can actually be solved. So you're actually finding the value of x and isolating the x on one side and getting an answer like x equals 2 or whatnot. Okay, so expressions cannot be solved, equations can. Okay, so and you'll see the difference. Of course, the first part of this review is a bunch of expressions, and then we get into equations as we go. All right, I talked about this one in class, but I'm still going to go ahead and work it again. These are all PEMDAS questions. And I know it's oh so tempting to take this 15 multiplier and distribute him, but you are not allowed to do that because if you multiply the 15, you're jumping to this step, right, to multiply. But you have parentheses and, more importantly, exponents, right? The fact that there's an exponent here is why you cannot distribute, because that exponent goes to the parentheses only and has nothing to do with the 15. So doing PEMDAS here is uber important and making sure you're getting it in the right order. So we're going to start with P, which is parentheses. So clearly 2.5 minus 1 is 1.5. So I'm going to cross that off. We've done the parentheses. I'm going to bring everything down. I'm still putting parentheses, of course, because I still have the power on the outside and the 15 multiplier in front. So these are not PEMDAS parentheses. These are just multiplier parentheses. All right, then I need to do the exponent, right? So I need to use my calculator, or you can do it in your head, I guess, if you want to. And you're going to use the power button, and you're going to raise 1.5 to the third power, which gives you 3.375. So I just did the exponent, so I'm going to cross that off, but I'm going to bring everything else down. Again, I'm still using parentheses because I still have that 15 multiplier in the front. All right, and now I am to multiply and divide, which you always do. They're on the same level of importance, and you always do them from left to right, whichever one appears first. So I'm just going to go ahead and do them both in this problem because I do have a multiplication problem here, and I have a division problem here. So I'm going to go ahead and just do them both at the same time. So I'm going to multiply that 3.375 times that 15 finally. Right now I can do it. So I get 50.625 plus, and then I need to do the division problem, which is going to give me 3. So those are done, right? And then last but not least, now I can do all addition and subtraction from left to right. And of course, there's only addition left, and that's where we're getting 53.625 as our final answer, right? So just make sure that you're using those PEMDAS rules. Now, as a heads up, hold on, give me 1 second. Okay. I would suggest on your test that you just type in, you can check your answers on these by typing in this entire original problem exactly as it's written. I'm going to show you what that would look like. Sorry, I'm going to have to go in. Here we go. All right, so I'm just going to show you what that would look like on a graphing calculator. Get rid of all that mess. Okay, I'm going to type the problem in as exactly as I see it on my paper, right? So 15 parentheses, 2.5 minus 1, close parentheses, raised to the third power. I'm going to use the right arrow to kick out of my parentheses. Then I'm going to type in plus 12, then divided by 4. And what do you know? 53.625. Right? So your calculator is programmed to do the order of operations. So it will tell you what the right answer is on these types of problems, right? The problems that don't have any X's at all. But do be aware, right? And I've said this a million times in class, that on your test, right, this step is worth points, this step is worth points, this step is worth points, and your final answer is worth 10 points. So if all you do on test day is type that in your calculator and spit out the answer, then you're missing 75% of the points for that problem just by putting the answer only. Okay, so just make sure you're showing those PEMDAS steps, okay? All right, number 5 is also a PEMDAS question. Please remember that numerators and denominators are natural grouping symbols, right? They're never going to put parentheses or brackets around all that, but you must simplify, right, the entire numerator and simplify the entire denominator before you can do the division of that fraction bar, which kind of goes against those rules. But again, technically we're doing parentheses first, okay? So we're going to do that top one. So negative 4 cubed, please remember, please use your calculator, right? Negative 4 cubed means negative 4 times itself 3 times, right? And so that's going to give us, and I'm just going to write it above if you're cool with that. That's going to give us negative 64. And then negative 64 minus 8 is going to give me negative 72 for my final numerator. And then, of course, in my denominator, it's just a subtraction problem, right? But it is a double negative, and a double negative means this is actually a plus sign. So it's actually negative 7 plus 3, right, which is going to give us negative 4. All right, and then we can just use our calculators if necessary and do the final division to simplify that as much as possible, and that is going to give us 18. Okay. All right, moving along. Now we're going to get to actual expressions that contain variables. So remember, once you start throwing variables in the mix, you're only allowed to combine like terms. Okay, so on this first problem, on number 6, the first thing that happens to catch my eye is that there's a ton of parentheses. And you're not allowed to touch any of this stuff that's trapped inside the parentheses until you've done something to get rid of the parentheses. And that means the distributive property. And guys, every single parentheses has a multiplier in front of it, whether you see it or not, right? This first parenthesis has an understood 1. So what it's telling me to do is multiply everybody inside by 1. Now, I know you're saying, well, that doesn't change anything, and you're right. But when I actually multiply everybody by 1, it does allow me to release the parentheses. All right, so now the 4n squared plus 5 is free to combine with other terms that look like them. And then, of course, on the second parenthesis, it's not just a 1, but it's a negative 1. So everybody inside is getting multiplied by a negative 1. Well, of course, a negative times a negative is going to give me a positive 2n, sorry, I'm going to keep it blue, a positive 2n squared, and then a negative 2n, and then a positive 4, right? Because when we multiply by negatives, it just changes everybody's sign, okay? Now, technically, this is step number 1. We've gotten rid of the parentheses, but we're not quite done because we have like terms. And I highly suggest, if it helps you visually, that you use a highlighter tomorrow on your test, right? Because I can only combine n squareds with other n squareds, right? And so I have a total of 6n squareds. Please make sure you're not actually squaring anything, right? It's that squared, this is an n squared term, right? I could say I have 6 dogs if I want to, or 6 cups, or 6 phones, or 6 pencils. Like, I can say 6 of whatever. They're just, the n squared is the name of the term. Okay, that's all it is. So that's why I can only combine n squareds with other n squareds to get more n squareds. Please don't actually square the 6 or anything else like that, right? That's just naming the term for you. Then I happen to notice that I have a negative 2n right here, but I have no other n terms because n's can only go with other n's. So I'm just going to bring him down. And then last but not least, I notice I have a constant of positive 5 and another constant of positive 4, which ends up giving me positive 9. And this is my answer, right? This is an expression, which means it cannot be solved, right? All it means to simplify is to distribute and combine like terms. That is literally all you have to do, and then you're done. Okay? Same thing on number 7, right? Very similar to the last problem. This parenthesis has an understood 1. So when I multiply everybody by 1, I'm still going to stay 3a minus 7. And then over here, everything's going to get multiplied by negative 5. Please make sure you remember that that sign, that negative belongs to the 5. So all the terms inside are getting multiplied by negative 5, which is going to give me negative 10a. And then a negative 5 times a positive 6 is going to give me negative 30. And of course, I'm not done because I happen to notice that I have 3 a's right here and negative 10 a's right here, which is going to give me negative 7 a's. And then I have negative 7 constants minus 30 more constants, which is going to give us negative 37 total constants. And that is our final simplified expression. Okay. All right, moving on. It says, we're talking about a rectangular parking lot, and part A says to draw a picture. You should always draw a picture, right? If you're talking about something that you can draw a picture for and label it, so much better for our brains to see that visual. So it says he knows the length is 5g minus 1, okay. And which side you're calling the length. I usually call the length the longest side, but it really doesn't matter at the end of the day. So just label 2 of your sides 5g minus 1, because of course every rectangle has 2 lengths, and every rectangle also has 2 widths, which this problem is telling me is 3g plus 6. So I'm going to label that. So all 4 sides of my rectangle, are labeled. I'm going to scooch this over here. Then it says to find the perimeter of the parking lot. Well, remember, perimeter means to add up all the sides. So if you want to, you can literally do 5g minus 1 plus 3g plus 6 plus 5g minus 1 plus another 3g plus 6, right? I'm literally just starting here, and I'm working my way around the perimeter of the rectangle, and I'm adding up all 4 sides. Okay, now you don't have to write all this out for me if you don't want to. You can just literally add it from the picture, but I'm just writing it all out right here just so I don't lose anybody. So now we're right back to all these expressions we just talked about up here, right? That's a lot of terms, and there's a lot of like terms. So we want to make sure that we add all the like terms. So I'm noticing I have a 5g plus 3 more g's plus 5 more g's plus 3 more g's, right? And that looks like a total of 16 g's. Then I'm going to go back through and look at my constants. I've got a negative 1 plus a 6, and then another negative 1 plus a 6. And I add all those together, and feel free to just throw it in your calculator if you want to, but that's going to give me 10. Right? And that is the expression that represents the perimeter of our rectangle. Again, I can't actually solve for g because I don't know what the actual perimeter is. If they told me the perimeter was 100, well, then I'm going to throw an equals 100 on the end of this and actually solve. And that's coming up later, right? But for now, right, that's all I can do. All right, we got more perimeter going on over here. So it says a triangle. Okay, I'm just going to draw myself some random triangle. It says it has side length 2x plus 1. And x, I know this is shoved really close, but notice the comma right there. It's 2x plus 1, right? Comma, x, comma, right? So x is actually one of the side lengths, and then 4x minus 3 is the third side length. So again, a picture always does wonders, right? To make sure that you have everything you need. And then we're right back to the last question, right? Oh, perimeter means to add up all the sides. I'm just going to start here. And I'm just going to mosey my way around the triangle and make sure I'm adding up all the sides. So x, I'll go in order. 2x plus 1 plus the 1x plus the 4x minus 3. So that is my expression of the perimeter, but we're not done because it's not simplified, right? We want to look for all of those like terms. So I've got a 2x plus a 1x plus a 4x. right? And that's going to give us 7 total x's. And then we're going to find that plus 1. Let me pick a different color. Let's use purple. Plus 1 constant minus 3. So that's going to end up giving us a minus 2 on the end. And that's it. That's our answer, right? Just looking for the expression that represents the perimeter. We can't actually solve it or anything because we don't have enough information for that yet. All right, number 10 is exactly like number 8, so I'm going to go through this one really quickly. It says draw the picture. All right. Side lengths, 2x plus 3, and of course the opposite side would be the exact same. And then x minus 4, same on the other side. So find a perimeter expression. Instead of writing it all out, I'm just going to do this one on the picture if you're cool with that. So I'm noticing on my picture I've got 2 x's plus an x plus a 2x plus an x, right? And so that's going to give me a total of 6 x's. If it helps you to write it out the whole thing lengthwise, then please do that. And then my constants, right? We end up with this plus 3 minus 4 plus 3 minus 4. And if I put all that together, I'm going to get minus 2. And there's the perimeter of the rectangle. Okay. So lots of practice problems there. So you can definitely assume on your test tomorrow that you're going to have perimeter questions, right? All right, number 11, this was also a question on our quiz that we took, our first quiz, or actually our second quiz, and it will probably be on your test again tomorrow. So it's asking you to solve this expression, or not solve, sorry, simplify that expression 2 different ways. So PEMDAS being order of operations, so they want you to use the PEMDAS rules for the first one, and the distributive property, right, where you get rid of the parentheses by distributing on the second one. So here we go. You should, of course, get the same answer, right? When you do, you're doing the exact same math problem. So when you get to the end of each column, you should be getting the same answer. You're just getting the same answer by 2 totally different methods, okay? So here we go. On the PEMDAS side, PEMDAS means parentheses, okay? So that's going to give me 4. I am going to keep mine in parentheses because it does have a multiplier in the front, right? So I did my parentheses. There are no exponents, right? Multiplication is next. So if I multiply 3 times 4, I'm going to get 12. So multiplication was done. Division, there isn't any. And then last but not least, I'm going to add the negative 4 plus the 12, and that gives me 8. Right? So I've done all my PEMDAS. I got 8. I should totally be getting 8 on this side as well because it's the same problem, right? So please don't get 2 different answers on your test. That doesn't make any sense at all. So the distributive property is we're going to distribute to get rid of the parentheses as opposed to adding and then multiplying by 3. We're going to just multiply. So I'm going to distribute that positive 3. So I'm going to bring down the negative 4. Oops, sorry. And positive 3 times negative 2 is negative 6. And then positive 3 times 6 is positive 18. And the cool thing is all I'm left with at this point is addition and subtraction. So those get done from left to right. So I'm going to do that. And of course, negative 10 plus 18, what do you know? Gives me 8, right? So we're getting the exact same answer just with 2 different, oops, whoa, sorry about that. Just 2 different math methods, okay? All right, on to this third page. Number 12 looks kind of crazy. It's a weird little question, but it's really simple, right? And if you don't know how to reduce your fractions, all they want you, this is clearly an x term, and this is clearly a y term. So you are not going to be able to add them together because they are not like terms. Let me put a little reminder here, not like terms. So all you're going to be able to do on this question is just simply reduce it as much as possible. So on this problem, I have the fraction 4/12. Again, if you don't know how to do that, I'm going to show you one more time on the calculator. So remember, you could do alpha, y equals, enter, and it puts a lovely fraction mode on your calculator. And if I type in 4/12 and hit enter, it's going to reduce the fraction for me, right? So if you need any assistance in that, right, use the calculator to your advantage, right? So that's going to give me 1/3. So I'm going to go back here. All right, the x is still in the numerator, but I'm just going to now change that fraction to 1/3 instead of 4/12. Now, me personally, I would not put the 1 up top because it's understood to be in front of the x anyway. But if you, oh, yikes. I made him so tiny. Whoa, what's happening? There we go. Just wanted to move them over. I'm not going to put the 1 because it's understood to be there. But if you want to write the 1 like I just had it a second ago, then by all means, that's totally fine. Then I'm going to bring in a plus sign, and then I need to reduce the 9/18, right? And again, if you need help with that, right, you can just type that in your calculator. Let me just show it to you one more time. So now if I do alpha y equals enter, I get my fraction mode, and then 9/18. And then if I hit enter, it tells me that that reduces to 1/2, which is awesome because then I can go back here and I'm going to get 1y, or just y, oops, over 2. And there's my 1/2 right here, right? So if you want to write the 1 because that looks nicer to you, then please do so, right? And so this is my final answer, right? This was just a little lesson in reducing fractions, but I still can't add these together because one's an x term and one's a y term, so they're not like terms, okay? All right, number 13, this is where we start getting into solving equations now. Number 13 just wants you to give an example of one solution versus two solutions versus infinite solutions. So I had that on the key before. I'm just going to split this into 3 columns if that's okay with y'all. There we go. Okay, so I'm going to go through this pretty quick. All right, so one solution. This is quote unquote normal. I'm going to put normal. It is normal for most equations to have one solution, right? So one solution means you have an equation like x plus 2 equals 5, right? So in order to solve that, I would move the 2 to the other side and I would get x equals 3, meaning x is the only value that I can possibly get when I am solving that equation, okay? No, or what was the next one? Yeah, no solution. Remember, this is what we call a special case, right? Special cases happen when your variables cancel and what you're left with is a false statement. So I'm just going to make up a super easy example of this. So let's see, something like x minus x plus 3 equals 7. Well, if I were to combine like terms, x minus x is 0. And I don't even need to write 0 x's. Like you just don't write any x's at all, like because they are completely gone and they disappear. And so what you're left with is 3 is equal to 7. But 3 is not equal to 7, right? So this is a false statement, right? And if you get a false statement, then that means your answer is no solution. Okay. All right, and then the last option when you're dealing with equations is infinite solutions. Just gonna abbreviate that, which is also a special case. Okay, so let's see. What if let me change my, there we go. I go a little lighter. All right, so let's say I did something like 2x plus 5 equals 2x plus 5. Well, clearly when I subtract my 2x's to get them all on one side, right, they all cancel out. So just like the previous example, all the x's disappear. It doesn't matter if they're on the same side to begin with or not. If your x's disappear anywhere in that problem, then all I care about is what I have left after that happens, right? And 5 is equal to 5, which is true. And if I'm left with a true statement, then that means that my answer is, sorry, changed my mind. Then that means my answer is infinite solutions. All right, so it's definitely important that you know the differences between all those guys. All right, so now we just have a ton of different examples of how to solve an equation. I did some of these with y'all in class. So if you want to fast forward here, you certainly can do so. All right, number 14. So the x's are already on the left, so that's great. Please remember your steps. I'm going to write them down one more time just for fun. So step number 1 is to distribute if you have parentheses. I clearly do not have parentheses in this problem, so I'm going to skip step number 1. Step number 2 is to combine like terms. Now that only means once I draw my wall, right, this is the left side. Do I have any like terms? No. My right side obviously is only one term, so no. So I would skip that step. Step number 3, variables, put vars to one side, right? At some point, you have to get all of your variables to one side. Well, I don't have to worry about that either in this problem because all my x's are already on the left, right? Once you do those first 3 steps, you should be able to solve the basic 2-step equation. You should always have a basic 2-step equation once you've done those first 3 steps. Now, I didn't need to do any of the first 3 steps because this is a basic 2-step equation. You just have to remember that you always move the number that is not directly attached to the variable first. Please remember you cannot touch the 12. The 12 is trapped in the numerator because this is a fraction. We already talked about how those are natural grouping symbols. That 12 is trapped up top with the minus x. So you can only move the 3. So the 3 is a divider, which means he will become a multiplier on the other side. All right, a divider on the left becomes a multiplier on the right if you want to move him over. So now let's see, that leaves us with 12 minus x equals 27. Now we can move the 12, right? So in order to move a positive 12, he's an adder because he's positive on that side, remember? Please remember the minus sign goes with the x, not the 12. So that 12 is an adder, which means he will become a subtractor when we move him to the other side. So that's going to leave us with negative x equals 15. And then don't forget, you're still not finished because that is a -1 multiplier on the x. And if I am a multiplier on the left, then I will become a divider on the right. And that gives us x equals -15. Now, you have the luxury on your test tomorrow, right? Whenever you have an equation that you can plug it in and check all of your answers. And I highly suggest you do that, right? Oh my goodness, I just messed the whole thing up. I'm just going to leave it like that. Because it takes less than 10 seconds and it will ensure that you didn't make a silly math mistake, because the only mistakes I'm really seeing on y'all's quizzes and homeworks are silly math mistakes, right? Like wrong integer math and that kind of stuff. So I'm going to check to see if x equals -15 is in fact my exact answer. So here we go. This one's kind of tricky. I talked about it in class. I'm going to go ahead and rewrite the original problem, because checking it means once I plug a -15 in for the x, so you got to be super careful on this one, right? Because if I plug a -15 in place of x, I'm just going to kind of scribble that out. I'm hoping you can see that that says 12 minus -15. So you end up with a double negative because one's a minus sign from the problem and one's a negative from your answer. So that actually ends up becoming a plus sign over 3. Does that equal 9? And then 12 plus 15 is 27. And what do you know? You end up getting 9 equals 9. Happy face, right? And I know without a doubt that -15 is my correct answer because when I plug it in, I get a true statement. Okay. Again, that took me less than 10 seconds and I was explaining as I went, right? So worth the time. All right, we're just going to do a ton more of these. I'm going to kind of speed up a little bit. All right, so on this one, again, you always move the number that's not attached to the variable first. These are attached by division. So it's the plus 15 that's not attached in this case, right? And so the first thing we're going to do, hold on, let me draw my wall. We got to get rid of that add 15. So an adder on the left becomes a subtractor on the right. So now I have t divided by 8 equals negative 16. And then I need to get rid of my divider, right? Because that 8 is a divider. And if I move a divider, he has to become a multiplier on the other side. Right? Again, it's not meant to be difficult, right? You just have to make sure that you're taking the number and you're moving it to the other side using the inverse operation, okay? Let's see, so that gives me the t all by itself, which gives me negative 128. Now, of course, I'm going to check that answer, and I'm going to take my original problem. Let me rewrite it again. T divided by 8 plus 15 equals negative 1. But instead of t, I'm going to scribble him out, I'm going to replace him with a negative 128. And then, of course, this ends up being a question mark because I want to know, does all that mess on the left equal negative 1? And so I'm going to divide by 8, and I'm going to get negative 16 plus 5. And negative, sorry, not 5, 15, which gives me negative 1 equals negative 1. And then I make a big smiley face because that proves that my answer is correct. Now, you don't have to show me all these step-by-steps, right? You can just show me this guy, and I'm totally fine with that. But just do as much work as you need to make that proof happen, okay? All right, number 16. I see parentheses. Let me draw my little equal sign. I definitely see parentheses on the right, so I'm going to distribute. So everybody gets multiplied by 3, so 3m plus 9. And on the left side, I don't have any parentheses, but I do notice that I have like terms. So I am going to be able to combine those. 7m's minus 4m's is going to give me 3m's. And then remember, once we distribute and combine like terms, our next step is to get all the variables to one side. Well, let's say I want to take those 3m's on the right and move them to the left, in which case I would be subtracting them. I'm like, whoa, my m's go cancel. All right, all the m's disappear because everything gives me 3m minus 3m, which is 0. So I know right away that this is a special case that I was just talking about right over here, right? And what I'm left with is what determines my answer. Right? I have 9 equals 9, which is true. That is a true statement, which means my answer is infinite solutions. Any number in the entire world would work for this problem. Now, obviously, you can't really check your answers on these because you're not going to sit there and plug in every number in the universe and make sure every number works, right? So you're just going to have to trust your gut on that one and make sure that you know how to work those special cases. Okay, sorry, I had to get a drink of water. All right, on number 17, we did this one together in class. There are multiple ways that you can work this problem because it has those fractions in it. I'm going to work it just like following the same steps that we've been doing. There are fancier things that you can do, but we haven't talked about those hardly, so I'm not going to do any of the fancy ways, but if you know what I'm talking about, then you're more than welcome to do that. So there is a way to get rid of all your fractions right off the bat, but I'm just going to work with the fractions. And you guys have a calculator, so there's really no reason why we can't let our calculators help us with the fraction math if you need it, okay? So the first thing I'm going to do is I'm going to notice that I have a negative 5 in front of this parenthesis, so I'm going to distribute it. So I'm going to go ahead and bring down my 14. And negative 1/5 times j is going to be negative 1/5 j. And then negative 1/5 times negative 10 is going to give us positive 2. All right, bring down my equal sign. There we go. And I notice I have a 2/5 on this side. So I'm going to go ahead and do that math. So that's going to give me 2/5 times 25. And again, I can't stress this enough. Hold on, let me go back to my calculator. I can literally type in alpha y equals enter and do 2/5 times 25, and it will tell me exactly what that is, right? So 10. All right, and then of course 2/5 times j is 2/5 j. All right, so that's step number 1, right? Distribute. Step number 2, remember all of our steps are written right here. Step number 2 is to combine like terms. And I do happen to have some like terms, right? Because I've got a 14 and a positive 2 on the same side. So these are like terms that should just be combined. So that's going to give me 16. And then I'm going to bring everything else down. Remember, organization is key, that we don't get lost in our own math work. All right, so we've distributed, we've combined like terms. Now we need to get all of our J's to one side. So you can either pick up these J's and move them over here, or you could pick up these J's and move them over here. It does not matter. I personally am going to go ahead and keep all my J's positive. So I'm actually going to take these minus 1/5 J's. And if they're subtractors on the left, they become adders on the right. All right, so that's going to give us, let me extend my little wall here. This is a long problem. So now I have left on the left is 16, and then 10 plus, and then I'm doing 2/5 plus 1/5. Again, if you don't know what that is, go to your calculator. All right, I can just type in alpha y equals enter, 2/5 plus alpha y equals enter, 1/5. Oh, that's not a 1. Sorry about that, 1/5. Right, and hit enter, and what do you know? 3/5, right? So I'm gonna go back here, and I'm gonna write 3/5 J. And now we're down to a basic 2-step equation. Now I'm going to start moving everything away from the J. Always move the term that's not attached first. So I'm going to take this adder of 10, and he's going to become a subtractor on the left. So that's going to give me 6 equals 3/5 J. And guys, don't freak out when you see fractions, right? That 3/5 J, he's a multiplier just like any other number. So I'm like, oh, J has a multiplier of 3/5. So if I'm going to move this multiplier to the other side, I'm going to divide, which I know looks kind of funky because it's like a fraction and a fraction. That's okay. 6 divided by 3/5. Now I can also type that in. There we go. You can type it in lots of different ways, but I always love to encourage the fraction mode. So you can actually put fraction modes within fraction modes. So I can do 6, and then I can go down to the denominator and hit another alpha y equals enter to put that 3/5 in that denominator. All right, and it's going to tell me that that is 10. I always encourage students to type things in on their calculator exactly as they see them on their paper so they don't get lost in translation of how to type them in correctly. And that gets us our answer of J equaling 10. Again, I would highly suggest, checking your answer, right? This is a really long problem. I mean, that was a 5-step question. And plugging that answer in to check it on a test would be such an amazing idea. Yeah, I don't feel like doing that. All right, because we have so many other ones to do. So I'm going to go through these again, try to be pretty quick. So on number 18, again, I'm going to kind of fast. So we have parentheses. It's the same steps over and over and over again, right? So let's see, that's going to give us 18K minus 12. And I'm going to bring down everybody else. All right, and then something I happen to notice is that I have 18 Ks and negative 6 Ks, right? So I'm going to put CLT for combined like terms. And so if I combine those on that side, it's going to give me 12K minus 12. Now what I happen to notice is now I have Ks on the left and the right. So if I subtract my 12 Ks to the left, we end up with that same issue as before, that all the Ks disappear. Now you have to be careful. So we have a negative 12 over here, but when everything cancels, you have to have something over on the left-hand side. You just can't leave it as a vacant hole. So it is 0. And then you ask yourself, is 0 equal to negative 12? Well, of course not, right? That is a false statement, which means my answer to this one is no solution. Please don't just write false on the test. I'll take off a couple points for not actually telling me that it has no solution and what false actually means. Okay. All right, number 19. Again, I'm going to go quickly. So we're going to distribute the 8. Sorry, let me get this going. There we go. So it's going to give us 8x minus 96, right, on the left. And then on the right-hand side, I don't have any parentheses, but I do happen to notice that we have like terms. So I'm going to go ahead and get those guys together, which is going to give us 8x minus 16. And oh my goodness, what do you notice, right? That we have the same issue. I'm subtracting the 8x from both sides. The x's completely disappear on both sides, right? And so that's going to give me negative 96 equals negative 16, which again is false. So this would be another no solution. All right, we put a lot of these on your review because we don't want you to freak out on the test when that happens, right? We just want it should just be commonplace, just like any other math problem, right, when that happens. Okay, so just throwing that out there. All right, number 20. So now we're to inequalities, right? So just be super careful. The only difference, or the only thing you have to remember, I'm going to put a little reminder here. Reminder. Right, you need to flip the inequality if you multiply or divide by a negative number anywhere in the solving process, right? So solving an inequality is absolutely no different than solving an equation, right? You just have to make sure that you flip the inequality symbol if you divide or multiply by a negative. And because when you divide or multiply by a negative, it changes the truth value. So you're responsible for flipping it to make sure you keep that truth value the same, right? We did that whole little exercise in class when we were doing our notes. All right, so on this one, I don't have parentheses, so I do not need to distribute. I do not have any like terms on the left or any like terms on the right, so I'm automatically going to step 3, which means I need to get all my variables to one side. Now, I don't care what side you move your y's to, but whatever side you move it to, it needs to stay on that side. So I'm going to move my minus 3y's over here. So a negative 3y or a minus 3y on the right is going to become a plus 3y on the left. Again, you don't have to do it just like I do. So I'm going to bring everything down, less than or equal to negative 31. Please don't forget to bring that sign down. He belongs with the 31. And then I'm down to a basic 2-step equation, right? I need to start moving everything to the other side away from the y's. So I have a minus 4. He's going to become a plus 4. So 9y less than or equal to, that's going to give me negative 27. And then I have a 9 multiplier. He's going to become a 9 divider on the other side. And that's going to give me y is less than or equal to negative 3. Notice I did not flip the inequality symbol. He stayed a less than the entire way down because I never once divided or multiplied by a negative number. I did divide into a negative number, but that doesn't matter, right? It's only if the negative number is on the bottom, right, that you flip the inequality symbol. All right, number 21. So here's my inequality symbol. All right, we always move the number. I don't have parentheses. I don't have like terms, and all my W's are already on the right. So I'm hopping right to step 4 because this is already a basic 2-step equation. We always move the number that's not attached to the variable first. So we need to get rid of that 17 adder, and he's going to become a subtractor when we move him to the other side. So that is going to give us negative 20 is greater than or equal to W divided by negative 4. And now we need to get rid of the negative 4 divider, in which case he will become a multiplier when we put him on the other side. And yes, indeed, I did just multiply by a negative, which means my symbol needs to flip. And that's going to end up giving me a positive 80. And just leave your answer like this. Please notice, I said this in class the other day, if your W is on the right, he should stay on the right the entire time. Please don't just magically move him to the other side for no reason, because that changes your inequality value. Okay, so just be super careful. Okay. All right, I'm gonna put a little reminder here, right, that we're gonna flip the inequality symbol, right? Because we ended up multiplying by that -4, right? That's why we did that. All right, hopping up here, number 22. Be really careful on this one. A lot of people on the test, if they see a question that looks like this, they will take the 5 and distribute him, but that 5 is not directly attached to the parenthesis, right? That 5 is just hanging out in the front, and then this is a -1, right? The number has to be butted up right against that parenthesis. All right, so we're going to distribute a -1, in which case this is going to become -0.36 minus 1x. Okay, so that's step number 1, distribute. Step number 2, combine like terms. And I have some of those, right? These guys are both constants, right? So I'm going to do the 5 minus 0.36, right, which is going to give us 4.64. So I'm going to change colors again. All right. Bring down my minus x, bring down my less than or equal to 7x plus 5. All right, so we distributed, we combined like terms. Now we've got to get all of our x's to one side. So again, you have choices. You can move this minus x over here, or you can move the 7x's over here. It does not matter, but you just want to keep the x's on whatever side you choose to put them on. I'm going to go ahead and add the x's to this side. So this minus x, he's a subtractor, so he's going to become an adder when I move him to this side. So here we go, 4.64. less than or equal, I have 8 x's now because I just added 1x to 7 x's. Right, and now I have a basic 2-step equation. So now I need to start moving everything to the other side. So my adder of 5 is going to become a subtractor. And that's going to give us, of course, we're going right back to what we had originally. So this is going to give us -0.36 is less than or equal to 8x. And then our 8 multiplier is going to become an 8 divider. Again, notice at no time did I multiply or divide by a negative. So it's going to stay, let me just double make sure I don't make a silly mistake. It's going to stay the original inequality symbol. Okay. All right, let's see, I'm typing that in my calculator. That's giving me -0.045. And again, if you moved your x's to the other side, you should get the exact same answer, right, with the inequality symbol opening up towards the x there. All right, number 23 is a nice, easy 2-stepper, right? There are no parentheses, there are no like terms, all your x's are already on the left, so who doesn't love that? So I know all I need to do is get rid of this 11 adder. He's going to become a subtractor when we move him over, which is going to give us 10. And then, of course, my -5 multiplier is going to become a -5 divider. And as soon as I do that, I'm like, whoop, dividing by a negative, flip. All right, I know that's going to make me flip my inequality symbol, so it's going to become a greater than and not a less than anymore. Right, and that's my final answer. All right, so flip that inequality symbol. All right, number 24, is y equals 2 a solution to this inequality? Well, I don't know, right? How would we check that? All right, well, we plug it in and see if it works, right? Does it give us a true statement, right? Does it make the statement true, right? That's the question that you need to answer, all right? Well, I don't know. I'm going to plug it in. So wherever I see a y, oh, there's one right there. I'm going to substitute a 2 in its place. So 14 times y, which is 2, plus 3, is that greater than or equal to 30? I'm going to put a question mark right there because that's what I'm trying to answer. Well, I'm just going to go ahead and do that in my calculator, right, if you want to. 14 times 2 is 28. 28 plus 3 is 31. Is 31 greater than or equal to 30? Yes, it is. Right, that is a true statement. 31 is greater than 30. So yes, y equals 2 is one of the infinite solutions of that inequality. Okay. You also, if you don't want to do it that way, here, let me just give you a secondary option. Right? This is option number 2. Let me just show you this. Because some of you guys, your brains might think this way. Some of you guys are like, well, I'll just solve it and see what I get, right? So that's always another option if you want to, right? You can solve this equation, 14y. I'm going to subtract the 3 to the other side, which is going to give me 27. Now, those are not friendly numbers, but that's okay, right? So 27, you're divided by 14, right? You're going to get like 1.9285, blah, blah, blah. It's an infinite decimal, right? So, but by doing that, you're saying y is any number greater than 1.9. Well, is 2 greater than 1.9? Yes, right? So you could also solve it and then see if the possible solution they gave us is in your answer. Okay, so that seems a little more difficult to me, especially if the numbers work out really gross there, like that infinite decimal, but it's certainly another way you could think about it. All right, number 25. Billy claims that x equals 4 is a solution to this inequality. Okay, well, let's see if Billy is right. I'm going to use the first option of just plugging in because I just think that's a lot easier. So 2 times 4 minus 5, is that in fact greater than 5 times 4 minus 17, right? So I'm just going to plug. Let me highlight here, right? I'm plugging a 4 in everywhere I see an x. And then I'm going to simplify that and see if I get a correct answer. So let's see, I'm just going to do it in my head, or you can plug it in your calculator. 2 times 4 is 8. 8 minus 5 is 3. 5 times 4 is 20. 20 minus 17 is 3. So I end up with 3 is greater than 3. Is that true? No, right? 3 is not greater than 3. It's equal to, and there's no equal to bar in this problem. So this would actually be false, right? And again, I know it's false because if I solve it, right, there'd be an open circle on the 3, right? And then I wouldn't be including that value. Okay, 26, whew, last page, here we go. On number 26, while at camp, you're given $100 to spend on goodies, right? So this is your maximum. Just pointing that out really quick. That is the maximum amount of money that you can spend. All right, you need a new pillow. Notice it says a new pillow, so that means 1, but also want some soda. The cost of a pillow is $60. Man, that's a good pillow. And each can of soda is $2.50. Write an inequality that represents this situation. Now, we talked about this in class. Remember with the cake mix and the icings that we talked about? So the first thing I always like students to do is identify what their variable is, right? What can vary in this scenario, right? It's not the $100. It's not the $60 pillow. It's not the cost of the soda, right? It's the number of cans of soda that you can afford to buy. That's what can change. Can I afford 1 can? Can I afford 2 cans? Can I afford 3 cans, right? So the number of cans you can actually buy can vary, right? So that's our variable. All right, so here we go. Let's talk about what you're spending. You spend $60 on a pillow plus $2.50 per can of soda, which would be X. Right, again, we love that word each, right? Anytime you see the word each, that's a multiplier word. Right? So each can, 250x. And then that maximum of $100, I'm not going to set it equal to 100 because that means I'm going to spend all 100, but I don't have to. It just says that's the maximum I have. So I know the amount of money I'm going to spend, which is on the left, must be less than or equal to 100. Okay, and that would be our inequality. So then it says, can you purchase 10 cans of soda? All right, so I'm going to do this 2 different ways. Please don't do both, right? Just pick whichever one speaks to you, right? So I'm going to do it just like I did the last couple of questions. Option number 2. Okay, option number 1 is to plug in 10 and see if you get something true. So 60 plus 250 times 10, is that going to be less than or equal to 100? right? So this is the plug it in method, right, to see if it works. Well, let's see. That's going to give me 60 plus 25, which is $85, right? Is $85 less than or equal to 100? Yes. Right? To me, this is the option I would always pick, right? If somebody asks me, is this a possible answer? I'm going to plug it in and see if it works, right? Now, option number 2 is you can actually solve it, right? I can solve 60 plus 250x is less than or equal to 100 by subtracting the 60 from both sides and then dividing that 60 by $2.50. And you're going to get x is less than or equal to 24. I'm just going to put cans, which basically means you can afford to buy any number of cans that is less than or equal to 24. And 10 cans is certainly less than or equal to 24, right? So 2 totally different ways to approach that answer or that question. I would take any of those on your test tomorrow. Okay. All right. Finally, we're on our day 6, which was literal equations. All right. This was that one that looked kind of weird at first, but I think a lot of us were really getting the hang of it by the end of class. So literal equations is when you have more than one variable and you can't actually simplify the stuff that you're moving to the other side. So number 27 says to solve for y. That means this is my variable I'm trying to get by itself. And you solve it just like any other equation, right? Just think about what would I do if all of these were numbers, right? If that x wasn't there, would you be able to solve for y? Absolutely. You would add the 4 to the other side and then divide by -3. You're going to do the exact same thing, except instead of just adding 4, you're going to add 4x. All right, the 4x subtractor becomes an adder when we move it to the other side. So I'm going to bring down my -3y. The only difference with literal equations is we're used to adding something over here that we can actually combine with what's already over there. But 9 and 4x are not like terms. So I literally just have to bring it down and just write it as 9 plus 4x. Right? Remember, literal equations really just means you're taking all the mess on one side and you're moving all the mess to the other side, right? It's still going to be a giant mess. You're just moving it to the other side using the opposite operation. And then lastly, we're going to divide by -3 to get that -3 multiplier off of the y. So we're going to divide all of this by -3. And again, just leave that as your answer. I'm totally fine with that at this point of the game, right? 9 plus 4x divided by -3. If you want to leave that as your final answer, that is great. I will totally take that right now. Your other option, we talked about this, and I'm going to just go ahead and mention it. Your other option is when it's a fraction, that means everybody could, if you want to, you don't have to, you can give everybody all the terms in the numerator their own little personal divide by -3. And that's the exact same thing. And the only reason we would want to ever do that is because this 9, this 9 divided by -3 can be simplified. I'm actually going to erase that instead of writing it out again. 9 divided by -3 is -3, right? And so I would also take this as a possible answer as well. You could also, of course, you could change this to a minus sign because of the negative that you're dividing by. So there's a lot of ways you can clean this stuff up and make it a tad bit more simplified. But guys, I'm totally fine with you just leaving your answer like this and calling it a day, right? We will focus more on that simplifying process when we get to like unit 3. Okay, so I'm not super worried about that right now. Okay. Number 28, it also says to solve for y. So there's my y, and I need to get everything to the other side. Well, how would you get it? It's the same thing as solving any equation. Pretend there's not an x there. What would you do? You would subtract the 6 and divide by 12, right? We're going to do the same thing, but we're going to subtract the 6x, right? So we're going to have 12y. I just can't do anything with 24 minus 6x, so I'm just going to leave it like that. And then I'm going to divide that 12 to the other side. So we're going to get y equals 24 minus 6x all over 12. once again, I will totally take that answer. Right, there's nothing wrong with just leaving it exactly like that. I'm totally fine with that, but I am going to go ahead and simplify that a little bit by giving everybody their own little personal 12 divider, because this I can actually clean up quite a bit, right? Because 24 divided by 12, again, I'm just going to erase that now, and I'm going to replace it with a 2. And 6 over 12 reduces to 1/2. So this is like an understood 1. You can write that if you want to, or you could take it off. Okay, so I can simplify all that down to 2 minus x over 2, right? And that would be the exact same answer. I know I sound like a broken record, but I can't say enough. You do not have to do this on your test if that is tricky for you, okay? All right, last few, here we go, number 29. We did a bunch of these on our homework, same ones. So it says volume equals length times width times height. That is the volume formula for a prism. And it says right now it's solved for V clearly because it says V equals, but they want you to rearrange it for whatever variable you choose, just not the V. All right, so I'm going to choose the L. Why not? It doesn't matter what you pick because these are all multipliers. So no matter which variable I get by itself, I'm going to be dividing. So I know that the L is getting multiplied by WH. So a WH multiplier is going to become a WH divider when I move it to the other side. And so that is my answer. Remember, you don't have to divide by W and then divide by H, right? Just do it all at one time because it's going to make it a lot easier for you to just do it in one step as opposed to 2 separate ones. All right, number 30. We did this one we did it in our notes and we also did it in our homework. So this one we've actually seen quite often. Right now, this is the perimeter formula for a rectangle, 2 lengths plus 2 widths. Currently, it is solved for P because it says P equals, but they want us to solve for L. So again, we're going to solve this just like we would any other problem, right? Imagine that that W wasn't there. What would you do to solve for L? You would subtract 2, divide by 2. We're going to do the same thing, except instead of subtracting 2, we got to subtract 2W. So that's going to give us P minus 2W, definitely not like terms, so we can't do anything with that. And then lastly, I'm going to divide by 2. Oops, sorry, let me keep my colors consistent. All right, so we're going to divide by 2. So that gives us P minus 2W divided by 2 equals L. And voila. Now you know what I have to say. If you want, you can give each one of those terms in the numerator their own little personal, divide by 2, and then simplify wherever you can. Well, the only place I can actually simplify is right here with this 2 divided by 2. And of course, 2 divided by 2 is 1. So I'm going to replace all of that with just a 1W. And that would be an extra step, right, to simplify that down to get L by itself, right? Again, don't do it if you don't understand it or if you don't want to take that risk. Totally fine with that. Just leave it as the original, okay? All right, last problem. Oh my goodness. Okay, we're trying to get this x by itself. Luckily, the x is in the numerator because whenever you have a fraction, remember, we don't want our problems to have fractions, so we want to get rid of the fraction. Let me rewrite that problem again really quick. I don't like how tiny he is up there. So I'm going to rewrite him. There we go. All right, so we're trying to get our way to this x, but I cannot get to that x until I do something to get rid of that y. Well, he's a divider, which means on the other side, he's going to become a multiplier. So now I have 8 plus 2x equals 10y. And now we're right back to every single other question that we've just been doing, right? I'm trying to get the x by itself. So clearly, just like any equation, we're going to subtract the 8, divide by 2, just like you would in any equation that we've been doing for the last 2 weeks. So I know I'm going to subtract the 8. The 8 adder is going to become an 8 subtractor. I clearly cannot subtract 8 from 10y though, because they're not like terms. So I'm literally just going to write it out horizontally. And then I need to get rid of that 2 divider. So we're going to turn him into a 2 multiplier. So I'm going to turn him into a 2 divider on the other side. So x equals 10y minus 8, all divided by 2. If you want to stop there, totally fine with that. Or, of course, you can give each term in the numerator that 10y, give him his own little divide by 2, and then the minus 8 gets his own little divide by 2. And you can see that we can simplify quite a bit here, right? Because 10 divided by 2, that's going to turn into a 5, and 8 divided by 2 is 4. Let me clean that spacing up. That looks really weird. There we go. Kind of, sort of. Make him bigger. Move him up. There we go. All right. So 5y minus 4 would be a just more cleaned up version, right, of this guy right here. Okay. Woo. All right. That was a lot of work. So there you have it. There's all your problems worked out on your review. If you have any questions, I'm always available for tutorials before and after school. So make sure you come in and ask before test day. Okay. All right. Good luck, you guys.